All right, thanks for joining us. We'll go ahead and get started. We've got pretty much 3/4 of the registrants that were registered for this is on here. So we're going to start with the part 2 of the 2021 IECC commercial changes. This is, as we said earlier in the week, that this is just an updated version of what we have done before. I did say that there was a 72 hours after the presentation to receive the course evaluation. Since this is part 2 of the part 1 and part 2, that you'll receive that course evaluation within 72 hours of this webinar, and then fill that survey out, send it back to Kathy, and you'll receive your course completion for both parts 1 and part 2 that will have the course ID number that will be equivalent to the 2-hour part 1 and part 2 together. So you can use that to turn in for your CEUs for ICC. I do have the chat feature open. We'll answer questions as they come through. Any technical difficulties, please post them in the chat. Any Q&A or questions that you need to have asked, please put that in the Q&A feature. And as we did on Tuesday after the presentation's over, I will just end the recording and we will start a kind of a live session of Q&A and go through that if you want to stay for that part of the webinar. So I appreciate you guys being here, and we will get started. Last time when we did this on part 1, we ran a little short on time, so we actually continued on into part 2. We're going to kind of go through that again and just stay on track with the part 2 of this webinar. So thanks again for joining us. The agenda is the same way. We're just going to go through and continue on. I won't go through the whole thing of who SPEAR is, but in the first part of most of our webinars start with kind of an overview of the code and how it's adopted and how it's written. So we're just going to jump right into it and go from there, and then we'll open up for the Q&A session as well. So we went through this on Tuesday, but I'll briefly go through it again. The Building Mechanical Systems 4 Commercial, the C403 chapter of that. With the 2021, we had quite a few changes that happened. The majority of those came from HVAC controls. 21 changes altogether, and with that was the HVAC controls were 7 of those. That deals with the monitoring, the HVAC monitoring, the default or fault detection monitoring as well for buildings over 100,000 square feet. Mechanical, the water heating as well, the performance and energy credits changes. There were some, as we said last week or last Tuesday, that 90.1 alignment is still happening with the commercial side of it. They're just kind of revamping the IECC to be more in line with the 90.1. It adds to clarification. It clears up confusion when people are in the cities that can do either 90.1 or the commercial section of the IECC. It clears up some confusion between the two standards that happen. With that, on one of them, on the addition, we have data centers that came through. So these are rooms that house communication, routers, anything that monitors the HVAC system, monitors security, any traffic. Those that are, if they have a data center that has centrally located internet capabilities. So these rooms are specifically set up, used to be called computer rooms, now they're calling them data centers. But there are specific sections of the ASHRAE 90.4 that need to be followed if it's deemed that this is a data center. Usually you would see those data centers being listed on the plans, but sections 6 and 8 of the ASHRAE 90.1 need to be followed. It's replaced the design mechanical load component. So what you're doing is switching out tables from the 90.4 with the tables in the IECC commercial section if it's listed as a data center. And that changes the value, the MCL, the mechanical load component values for those specific tables. There are different requirements when it comes to how much energy consumption can happen in just those data centers. So that's something that's been broke out and separated from computer rooms and listed separately in the code. This is just the table kind of showing the maximum design MCL, and it's based on climate zone. So whichever climate zone you're in, this will be your maximum design load that you can have for those data centers. And then the next one is for the annualized mechanical load component of that same room for the data centers. It just gives you the idea, or not the idea, it gives you the requirement of what the maximum MCL can be for those data centers. So that's something new that a lot of the code officials and third parties are having to learn and understand what it means to be a data center, how to extrapolate and look at and calculate what the power usage is going to be, and then actually be able to define that as either a data center or just a small storage room with some computer equipments may not meet that requirement or the definition of a data center. So that needs to be determined from that. So fault detections, I kind of briefly talked about that a second ago, but HVAC systems serving a gross condition floor area of 100,000 square feet or larger shall include default detection and diagnostic systems. So this includes permanently installed sensors and devices for monitoring the HVAC performance. It samples the HVAC performance every 15 minutes. It can automatically identify and report the faults. It automatically notifies a authorized personnel, a maintenance guy, or someone that's in charge of maintenance for the building. It automatically provides prioritized recommendations for repair. It can identify faults, saying that if it's a switch or if it's a pump or if it's some other kind of mechanism, is if it's in need of repair and or replacement, it can identify that and notify the personnel, and then also be capable of transmitting that prioritized fault repair recommendations to remotely located authorized personnel. So if there's someone off site, maybe there's a command center somewhere that actually monitors several buildings, they need to have that in there to be able to get those fault recommendations. There is exceptions for building types R1 and R2 occupancies. When we talked about this before, I still am not really clear on if it's a warehouse that's 100,000 square feet, but 10,000 square feet of that is office, meaning that the building is not 100,000. It does say gross condition floor area, so my understanding is whatever's under roof for the entire building. So if it's 100,000 square feet but contains a 10,000 square foot office space, it's not a 90,000 or 90,000 square foot building. It's still 100,000 or greater. So this would still fall into place. You would still have to have this monitoring system. There are specific equipment out there now that you can purchase and be able to hook it up. It's kind of a plug and play thing. Codes sometimes get ahead of themselves, and there's not manufactured equipment that will handle these kind of things. But these things are readily available out there, and it's just learning and understanding what those reports look like. But these systems need to be set up. Same thing with HVAC systems, though, is these things, even though they're installed, you need to see evidence of the fact that were they commissioned and are they running properly? Are they connected properly? Are they reporting properly? And will it handle the faults as needed? And who will be the person that's actually being remotely notified of any fault detections that are happening? So there's more things that go into that than do they have these systems? Yes, but it falls into the category of, well, if it's commissioned properly, the information comes to, does it handle all of these 6 criteria that are listed for the fault detection and diagnostic systems. Also is the automatic start and stop. This just kind of basically says anything that has a digital control, which most of them all now have that, and they're all working individual zones. Automatic stop controls shall be configured to reduce HVAC systems heating a temperature set point and increase the cooling set point by not less than 2 degrees before the scheduled unoccupied periods based on thermal lag and acceptable drift in space temperature that are within those comfort levels. And then also automatic controls shall be configured to automatically adjust the daily start times. So if it's supposed to come on at 7 and it's 5:45 and it's still an increase in temperature, but it's too high, and it now knows whether or not it's going to get to that point when the system kicks in, when someone occupies the building, it can start prematurely to occupant. So Ben's put in the chat or Q&A section, 112,000 square foot building with only 20,000 conditioned floor area and the rest is not conditioned would not be required for FDD. Okay, that's great. So with me not saying that, so it's going to be 100,000 square foot that's conditioned. That's true. So if the other greater portion, 70,000, 75,000 square feet, 80,000 square feet is not conditioned, it does not fall into that category. Thanks for that clarification, and that does make sense. And of course, it did say anything with HVACs that are 100,000 or more. So if you've got some of these new greenhouses, some of these grow warehouses, or if it's just a large manufacturing plant that's being heated and cooled and air conditioned, the large Tesla plant in Austin, heated and cooled, that would fall under that category. But yes, If it's not actively being heated and cooled, then that portion of the building not being conditioned is not included. So thanks for that clarification. I appreciate that, Ben. And so just these automatic starts and stops, you got to have these controls. Again, it goes back to just the lighting part of it, the HVAC part of it, the mechanicals part of it is just to have it's one thing. The second thing is it commissioned properly? Does it function? Does it actually do what it's supposed to do? Does it have the setbacks? It needs to be tested to make sure that it actually functions properly to meet the requirement of the code. And then fan efficacy. This is something new. It's rolling also into residential, but in commercial side of that, you've got fan efficacy metrics that are updated with the energy index, just kind of looking at what's the efficiency of these fans. You've got ventilation fans, you've got economizers, you've got just warehouse ventilation fans that are set up in there, and then they actually need to meet a certain efficiency for that. So they defined like fan arrays, if there's a bunch of them that are listed in there. The FEI for fan array shall be calculated in accordance to what's called an AMCA 208 Annex C. The AMCA is an actual standard, which is Air Movement and Control Association, and they have a 208 that's free for download on the amca.org if you wanted to take a look at that part of it. They have low capacity ventilation fans, new requirements for low capacity ventilation fans that supply ventilation type for residential construction and mid-rise residential occupancies in small commercial buildings as well. There are exceptions to that. So fans that are a component of the HVAC. So if it's designed in the system for HVAC, then it's exempt. And then also dryer exhaust duct power ventilators, domestic range hoods, and domestic range booster fans that operate intermittently. So if it's not something that's autonomous and working on temperature settings or time settings, if it has to be turned on and off, then it's going to be exempt from that. So these are basically on motors that are less than 1/12 of a horsepower must meet the fan efficacy because it's a low volume, low CFM, and they don't want to use and drain a lot of power for just very little air movement. So they put efficacy labelings on that. This is the table that's showing that in the code. It does list ERVs, HRVs, that's part of mechanical ventilation, inline fans, which is kind of new to the market like 2 or 3 years ago, but they're standalone ventilation fans. If you've got exhaust only fans, such as bathrooms or utility fans, or kitchen exhaust that are actually deemed part of the ventilation, it actually does still need to meet a minimum efficacy, which that is CFM per watt being used. And as you can see, it breaks it up into categories of min and max for CFM. You got 10 to 90 for bath fans needs to meet a 2.8 CFM per watt, and then 90 and above is 3.5. So that's basically measured by how much wattage is drawn on that and how much CFM. You can look at the manufacturer specs. Usually there's a sticker or a label that's posted on the fan itself, and you can look at that. Or if you're looking at the design and you're looking at a list of equipment that's there, just in making sure that those are installed and they've used the one that they've actually deemed in the design, you can see that and look at the watt draw and CFM rating capacity for those fans, making sure those meet that requirement. Operable openings and interlocking controls. Last Tuesday, we talked about the ones, we showed one for a restaurant. This is talking about loading docks. As you can see on the loading docks, there is skirts on the top and bottom of the loading docks that actually meet and marry up to the end of the tailgates of the semi-storage. And that keeps heating and cooling inside the building itself. But those also should be interlocked with the HVAC, where it changes the set temperature to 90 degrees for cooling and 55 for heating when the conditions exist in C402.5.8. And these controls should also be able to shut it off completely if the outdoor temperature is below 90 or above 55 degrees. So if it can actually handle and no one's going to be complaining that it's too hot or too cold with those doors being open, it should just shut off the HVAC system entirely. But if it's beyond those parameters, either too cold or too hot, above 90 degrees, it's going to basically just turn up the thermostat or turn down the thermostat and not have it blowing at 72 degrees or 68 or 70 degree heating, and actually have it pouring to the outside. So those things need to be handled for loading docks. They still are required to have either weather seals or some kind of restriction for infiltration when it's actually being used for loading. If you're looking closely on this picture, that second door there is actually left wide open. So if that door is open and it's part of the interlock, then that would actually change the settings for the thermostat or the HVAC in there, just because that door is halfway open. So need to have those interlocking controls. Now this is the new part of it we'll go through. We did have that a few weeks ago. We had a couple of presenters that actually talked about more in depth the electrical power and lighting systems. So I'm just going to kind of go through this and just what it looks like from the changes. There were 19 proposals that made it into the 2021 IECC for lighting. The majority of those is controls, because if they've already got the majority of lighting a high efficacy or LEDs that are in there, the only way to now to curb energy consumption is to actually lower the time it's actually being used. So we've got 13 for controls, we've got 3 for general and 3 for power allowance. And then by proposal, we had the majority of those coming from daylighting. So if you've got windows or skylights that are in your daylight zones, we've got to have sensors that either turn them down by 50% or shut them off entirely if you've got enough lighting from outside to actually be able to have occupants work without straining their eyes. And you've got occupant sensors. We got 2 for exterior, 1 for digital controls, and 1 for parking garage. So those just continue to change. We always like to say, gone are the good old days for low-hanging fruit, because it used to be that you just had to change to high efficacy lighting, which was easy. Now they want you to control how often those things are used. Parking garages are getting more and more complicated with kind of just, it's no longer just an on or off thing as well. It's got to have controls that monitor how much light's coming through. General lighting, it was just a little bit of a modification with that. So lighting system controls and maximum lighting power for interior and exterior applications, and lighting energy consumption shall comply with this section. Sleeping units, if there's a sleeping unit, say in a warehouse or a training facility that's mostly a warehouse, but there's sleeping units with there's specific sections that now need to be followed. General lighting shall consist of any lighting including that's included when calculating the total connected interior power light. So if you're looking at design, you're looking at its total interior power, everything's included, is just considered general. And then transformers, uninterruptible power supplies, motors, electrical power processing equipment in data centers shall comply with the Section 8 of ASHRAE 90.4 for that. So again, lighting is not as simple as it used to be. There's some confusion in there. It's going to be, you need to read 2 different sections of the book, or you've got to reference the ASHRAE 90.4 to see if it falls under a certain category. There's just some changes there, and that continues to be modified for clarification. Another one for that was just basically not less than 90% of all permanently installed lighting serving the dwelling units, excluding kitchens, appliance lighting, shall be provided by lamps with efficacies of not less than 65 lums per watt. So that's how much lighting's actually happened divided by the watts that's used, or luminaries with the efficacy of not less than 45, or shall comply with another section of C 405.2.4 and 405.3. So daylight responsive is getting involved with that as well. On sections 405.2.4, that's the daylight responsive controls, and section 405.3 is the interior lighting power requirements. So there's different ones. So you're looking at 405.1.1. It just says lighting for dwelling units, and then it's referencing 2 other sections that you need to also take into consideration when verifying compliance. The occupant sensor controls in warehouse and storage, that again is becoming more and more defined, and requirements for restricting light usage of unoccupied warehousing. That includes lighting of aisleways. So if you've got different aisleways inside of a warehouse, they shall be controlled independently of all other lighting of other aisleways. So if you've got aisle 24, someone's working on there and using that, and they're actually either getting equipment down or they're storing something on the shelves. If aisle 15 isn't being occupied, it needs to have lights that either turn off by 50% within 20 minutes, or could also just turn off entirely and not be turned on. So a lot of times you see that these days now in grocery stores, they're doing that as well, especially in the freezer section. You'll see as you walk into those aisles that haven't been occupied for a while, the lights start to turn on as you walk past them. That's what we're talking about. It can turn it down by 50%. That can be done by turning half the lighting off or dimming the light. Sometimes dimming them is harder to do depending on what kind of luminaries are being used. It's easier just to put them on different circuits and have half of them turn off. So occupant sensors shall automatically reduce the lighting, and then lights that are not turned off by occupant sensors shall be turned off by a time switch control. If there is a manual control, basically it's saying that it shall be provided to allow occupants to turn off the lights in the space. They also want to know that if someone turns it off or on, will it actually go back to being automatic after a certain point? So there should be controls that are set up, not just a manual switch where you can flip it off entirely. Maybe it's a button that you push to actually turn it on, but it will go back to automatic settings after a certain time and still meet the requirements of these occupant sensor control functions for warehousing and storage areas. So light reduction controls, so it's just a clarification. We're not provided with occupant sensors. General lighting shall be provided with light reduction controls. Following sections 405.2, that should be 0.3.1, I think. It's a typo there. Exception, you got luminaries controlled by daylight responsive control. So if it's already got a daylight responsive control, then it doesn't have to have additional controls. Then you got luminaire controlled by special application controls. So if it's a time switch or something else that's set up, maybe it's a monitoring system that runs the lighting for the warehouse. And then we're provided with a manual control. The lighting areas are not required to have light reduction control. So spaces that only have one luminaire that is only rated for power less than 90 watts. So if it's just a small little area with one lighting that's only 90 watts or less, it doesn't have to have a control. Spaces that use less than 0.45 watts per square foot. So you can calculate how many watts are being used by the square footage and the power usage for those lamps. And then corridors, lobbies, electrical rooms, and other mechanical rooms, places that people need to have lighting in there for safety reasons or to illuminate exit signs. Those don't have to have occupant sensor controls in them. There's a lot of people that are kind of against occupant controls, and it makes sense as the people don't really want to deal with all of that, but they're trying to make it easy to where you can still have exceptions in there that doesn't have things like lobbies and corridors and things that are public safety reasons to turn off, and they still have to have lighting that's in there. Parking garage lighting control, I talked about that just a second ago, but new provisions for lighting in parking garages recognize parking garages as a unique space. So it's kind of separating that and saying, okay, well, now you're going to have to handle this differently. It requires such spaces to have either occupant sensors or time switch controls. So parking garage lighting shall be controlled by an occupant sensor complying with sections 405.2.1.1 or time switch controls complying with sections 405.2.2.1. That again is you've already got high efficacy lighting. You've already reduced consumption of energy by the lights that are being used for that purpose. Now we just need to have them not used as often or not left on all the time. So those things need to be changed. And then also with that is addition is lighting power with luminaires shall be automatically reduced to not less than 30% when there's no activity detected. So it's not asking it to be turned off entirely. It's just reducing the energy that it's using by either turning off some of them or being able to dim them down 30% when no activity is detected for 20 minutes. And then we're lighting for eye adaptation. So if you're coming in from a sunny day and you're walking on the sidewalk to get to the parking garage and you step into the parking garage, it takes a moment for your eyes to adjust. They don't want people tripping over hazards or having unsafe reasons walking out in front of a car or just having dark spots in there. So they will allow for lighting for eye adaptation. It is provided at entrances and exits for lighting shall be separately controlled with a device that automatically reduces lighting by 50%. So not going down as much. So you don't have to have that sudden eye burst of light, or you walk into a parking garage and it's very dark and you can't see and you trip over something. And then the power luminaries within 20 feet of the perimeter wall opening shall automatically reduce in response to daylight. So if you've got an open area parking garage and the outside perimeter has openings to the outside for ventilation control as well as for lighting, Those lights that are within 20 feet of that perimeter wall shall also be automatically reducing the lighting by 50%. Again, that can be half of them going off or reducing the lighting power altogether. So there are some exemptions. I didn't list them here. There was a lot. This is a big section that's in there. It's something really more clarified, defined, and modified to meet more requirements for energy consumption, to reduce energy consumption in parking garages. So that's a big section to look at. The majority of apartments and things now, there's a lot of parking garages being built, not just open parking lots. It's being parking garage to conserve space and not use so much land to do that. We've got lighting for plant growth. So we've got grow houses. We've got, right now Texas isn't they haven't passed the law to be able to have grow houses for marijuana or CBD, but there are horticultural things coming up, hydroponics, tomato farms, anything to grow plants to be able to help feed the masses and population. So there's things that are now specific to lighting for plant growth. So with this is addition of provisions regulating lighting for plant growth and maintenance shall be added to ensure the indoor agricultural operations are energy efficient. There's actually a standard. It's ANSI or /ASABE S640. So that is a public standard that stands for quantities and units of electromagnetic radiation for plants. So it's a way to look at, yes, is it meeting the efficacy of the lighting? Does it have enough electromagnetic radiation for the plants to be able to grow using that lighting? But is it also energy efficient? So not less than 90% of all permanently installed lighting used for plant growth shall meet and shall have a photon efficiency not less than 1.6 per joule as defined in that standard. So you can look at that and see at the lighting. You can look at the design phase of it, look at the S640 and try to see how much photo efficiency energy, how much electromagnetic radiation is happening with those lightings per the amount of energy being used to make sure it meets that efficacy. The last thing too is just little additional notes here. Parking garage lighting, there's more controls. Not all of them are listed here. More occupant sensors. I didn't list all of them for warehouse aisle independence or manual controls that are required. There's general lighting for decorative exemptions as well. There's enhanced controls. If the building has a sign out front, it can probably illuminate the sign, but anything that's beyond that, you need to look at controls for that to shut it down. Exterior lighting, additional dimming requirements. So that's parking lots, that's landscape lighting if it's not low volt, if it's high volt lighting that's set up for that for like a retail space and or a large warehouse space, it needs to also have controls that happen with that as well. So automatic receptacle controls, those two that we had doing the presentation, they went through this in lengthy detail, but I'll just kind of go through this for a higher level. So new provisions require at least 50% of covered receptacles and 25% of branch circuit feeders to be automatically controlled receptacles. So as you see in the photo here, it's a little blurry. Sorry, I blew it up. It was a smaller picture. This has a USB port on it, but it has that little Wi-Fi looking signal on it. That means that it is controlled. This doesn't have a label of whether or not it's both plugs or just one. Usually when you'll see it, it's labeled to where you can really tell which ones are done. This is going to be the whole receptacle. It can be turned off by the manual switch there, or it can be done automatically, which it should be, and it will actually say that on there. So actually, if you look close, the one on top says controlled, the one on bottom says on. So more than likely that means the top one is the one that's being controlled. So you don't have to shut off an entire plug outlet. You can shut half of it off. So if you have a corridor with seating or a lobby with seating, or you've got dorm rooms and common areas, kitchen areas, cafes, these lightings, these plugs that are around there, they don't want people just plugging them in and leaving either a laptop plugged in or having some kind of phone chargers that are plugged in and just left draining power all the time. So those are what they call vampire draining amps. You don't want to just keep pulling vampire watts out of the wall. So what they're going to do is require that 50% of those receptacles and 25% of the branch circuit feeders need to be controlled automatically to be shut off at a certain time of day. So that's something that people are having confusion with on how to set those up, which rooms are actually required to have that. Most of the time, it's in dorms, it may be even in the dorms themselves, but the majority of the time, if it's in an office building, it's going to be in the common areas where you have seating that for the general public, or you have common areas for offices of meeting rooms, not really in the offices themselves. It will be in a common area. So that's requirements that are in there listed in those books to be able to, I didn't put everything in there. That was just kind of the addition that's going on. But as you can see, a lot of it's more and more and more controls. So energy monitoring is required to be as an added measure and to retain the intended energy performance of a building. So right now, energy monitoring is 25,000 square feet or greater. In a minute, we've got a sneak peek of the 2024 proposals that already made it through, and it actually reduces that to 10,000. So if your city's going to go to 2024, that energy monitoring requirement will actually drop to 10,000. But this 25,000 square feet or larger needs to be monitored. Electrical energy monitoring, metering, in-use metering categories, separate meters. This is a big, lengthy category. I didn't put everything that's in here just because it is kind of confusing. You have to read through that and just to see what all we're going to look at, what all we're doing. But if you've got a big warehouse that's broken up into different rooms and different areas, as long as there's not one big area that's 25,000 square feet or more, then you more than likely you probably would not have to have that. So there's exemptions for first for R2 buildings. Monitoring is not required if it's own utility services and meters. If it has its own, like some of the colleges will have their own utility services and meters, and has less than 5,000 square feet of conditioned floor area. The exemptions for in-use metering are HVAC and water heating servicing individual dwelling units. Only those individual dwelling units. If it's actually serving a general population, it is not exempt. And then for fire pumps, stairwell, pressurization fans, and other emergency systems as well, those are exempt. And then for individual tenant space having floor area not greater than 2,500 square feet, where a dedicated source meter needs to comply with C405.12.3 is provided. So it's just a big, lengthy process of looking at that, but this is something new. It's the energy monitoring side of that. Needs to be able to do a graphical energy report. Someone needs to be able to look at that. Some of the colleges and or schools and dormitories with individual buildings have already been doing this for a while now, especially the ones that meet the LEED, like a LEED high performance building requirement for certification. They're already doing this monitoring. They have control rooms that have the monitoring set up. They could look at each building individually. They're not really worried about doing specific plug monitoring, but they're looking at room monitoring or building monitoring to see, do you have something that's got an issue happening? Where this can come into play is you have dorm rooms or apartments where someone has set up a Bitcoin mining system where they're actually drawing a ton of energy. Yeah, they're probably paying for it through their utility if it's a apartment, but if it's a dorm, they're using a lot of energy consumption through that area. And you don't need to be having that. So if you can narrow that down to a building and try to narrow it down to a room, you can find out that somebody's taking advantage of the energy, the free energy use there to set up Bitcoin mining for that. So additional efficiency requirements. When complying with prescriptive compliance options, designer may select from a 10-point based additional energy efficiency options that's now considering the climate zone occupant type. So this is, you've already followed the code, you've followed the prescriptive compliance pathway, you've gone through all of that, but now we have this table like this that now has all these different performance measures and energy efficiency improvements that are based on each climate zone that is awarded a certain amount of points. And at the end of the day, you have to have 10 points to meet that specific additional efficiency requirements. A lot of cities are amending this out. They're not really trying to ask for this to be done. This is kind of the meat and potatoes of the reduction in energy consumption for the 2021. So we say it's about 8 to 9% efficiency improvement. But if you take these things out, you kind of lose that improvement. You're almost really back to the 2018 with a little bit of adjustments and modifications. this is another enhancement to try to get buildings more energy efficient, is not demanding certain things. It's giving owners and designers the option to say, there's a whole list of options, pick from these, but at the end of the day, you've got to have 10 points total. Some of these, as you see, if you're in climate zone 0 or 1, or even 0 or 1A or 1B, if you did a 10% cooling efficiency improvement, you've already got 11 or 12 points and you're done. But if you're unfortunately in climate zones 3, 4, 5, and 6, there's really not a massive point awardment for any one category. I mean, reduced power lighting is pretty high up there. And then on-site power generation has 9s across the board, regardless of what climate zone you're in. But those are expensive. So if you don't want a lot of cost being added to the building, then you just pick from some of these, but you've got to add these things up. We just talked about energy monitoring and how much that may cost a building by having to monitor that. But the highest points awarded is 4, and that's in the very southern part of the country. So if you've got climate zone 3B, 4B, 5B, you're only awarded 3 points for that. You got 7 more to go. So it can get confusing. On the residential side for the 2024, this same scenario is being brought into residential. So they see that it's being successfully done in commercial as long as it's not amended out in the city. So residential is also taking upon this 10 credit achievement to be done for depending on your climate zone and which one you want to do. But as you see, it's going to be broken up. At the very top of this chart, this is just one chart of many. The top one, this says this is group B occupancy, sorry. Whoops. And then there's also several building group types as well. And the chart changes based on points because it's awarded different points for that. But there's group R and I is one table. Group E is its own table. Group M is its own table. And then there's another one that just says other. So there are several charts that you have to look at. So first you have to identify what type of building occupancy is it. And then you look at the table and define which one. That's usually done from the design standpoint. They're usually going to give you this stuff on their design report. You're going to just be able to clarify, are they using the right table? Is it the right occupancy table? And then just look at those points and what they're claiming that they're doing. And then look at how many points they have and just make sure that you've got 10 that's added up to that. But as you see also, there's some of them that has NA. Some climate zones adding 10% heating efficiency because you just have to oversize your heating to meet cooling. You're not really awarded any points in 0 through 4 on the climate zones. It starts in climate zone 5 and goes up. You're not awarded those points. So you can't really get credit for things that you're not trying to do just because you have to oversize your heating unit to meet loads for cooling in the warmer parts of the United States. You're just not automatically awarded points for that. So there still is total building performance compliance pathway that can be done. Same as residential section of this book, the word mandatory has been removed. So now there's just a table that says, well, this list of things that are here, and it's on the next slide. The list of things are what you're going to have to do, and they're required to do. It's the same thing as mandatory, but that word was taken out and removed from the book. But now also when you have a referenced building or a project that's being built, you're comparing it to the referenced building or project in a software. And to be energy compliant, you need to be at or below the annualized energy consumption for that building. Now it's saying for the total, it's actually reduced it down to 85%. So you don't have to be, you can't be dollar for dollar. Well, I'm the same because we're meeting dollar for dollar. You need to be at 85% of the referenced. So that's just making it more energy efficient by just dropping that standard down to say you're going to be only 85% of the standard reference. I believe in 18 it was either 90 or 95%. Now they're dropping it 85%. Another way to just get more energy efficient measures being put into those buildings to meet that requirement if you're following performance. And this is, of course, the requirement table for the total building performance section. These sections on the left still have to be followed. They cannot be skipped. And on the right, you see that's just the title of what you're doing. So you've got system design. You've got data center section that's still included. You've got air leakage thermal envelope, which you can do testing or you can do visual inspections only for that. You've got fan and controls, you got larger diameter ceiling fans, you got service water heating. I won't go through all of that, but there's still required sections that are doing when you go through performance. Performance usually done because you've got easy trade-offs. Okay, thanks, Sean. So it was even 85% all the way from 2015. Thank you very much for that. As you see, I'm learning more and more with commercial side of that. I've been residential for 10 years, and commercial, I'm just starting to learn a lot of that part of it and go through that. So thanks for that clarification. It has been 85% since 2015. I appreciate that. So that's kind of conclusion of the 2021. This is kind of a sneak preview of some of the things that's actually made it into the 2024. It will be published and I believe out for public consumption for January 1. There's been public comments on there. I think they're going through publication now or trying to get that done. This is kind of some stuff. I brought it off of the New Buildings Institute website. They are just posting the ones that either have made it or made it by modification, or some of them that's actually been withdrawn. This is not a lengthy, it's not a list of all of them. It's just a list of the ones I put up that I thought was pretty surprising. So you've got air barrier testing. So it increases the building size threshold for testing to 250,000 square feet and reduces the allowable air leakage to 0.25 CFM per square feet. So that's going to be if it's being air tested. I think there's still going to be that allowance to be able to say that you could do testing, or you can also do like a visual inspection side of that. Then you've got the horticultural dehumidification. So approved as modified with the new ANSI standard and the way they're doing and following more of an ASHRAE model. You know, someone proposed this, it was denied, but they said, if you go back and modify this, we'll take a look at it again. It was modified, and then it was approved as modified because they made suggestions, but it increases the efficiencies of dehumidification systems and horticultural applications. We'll see more and more of these things as just the need for food and food that is grown at either more of a rapid rate or just not having it in such a hotter climate or bugs infestation. So they're able to grow more food. These things are happening more and more. Also, horticultural lighting. So it increases the stringency for lighting of the horticultural applications. You've got energy monitoring. I just talked about that a minute ago, but it was 25,000 for the 2021. It's dropping it now to 10,000. And it also to align with common benchmark policies. So it's just reducing that to get that. It's kind of like they want to introduce it to you. They're given these large allowances to say, well, if you're under 25,000, you don't have to do this. Now they're dropping it to 10. It's already out there. Usually that's also giving time for manufacturers to more produce a cost-effective means to be able to use this equipment instead of it being outpriced for most buildings that are under 25,000 square feet. Then it'll change to 10,000 for 2024. And then energy monitoring for EVs. So EVs and solar ready and EV plug-in and EV charging stations are now requires a sub-metering for EVs where it's installed. So if you've got EV charging that's happening, the majority of all warehousing and cities that are adopting 21, also ironically Houston, which is wrapping up their adoption, they're pulling in from the 2024 and taking some of this EV and charging station requirements to make sure that they're ahead of the game, knowing that a lot of buildings that are being built, they're putting one or two energy EV charging stations in. They want to know how to handle it. There's already approved codes that are out there that have been done for those types of applications. So to stay on point, they're actually going to pull these 2024 requirements into their 21 code to be able to have that ready when they're being used. Commissioning, it reduces the thresholds required for commissioning of a system. Again, you've already got energy efficient stuff, but you've got high level square footage. They're going to start lowering that. Now there's reducing the thresholds for that. Multifamily alignment. Someone threw that out there to be done that requires multifamily alignment across commercial and residential. That was disapproved. They don't really want to try to say that you're going to have to follow residential. If it's 4 stories or more, it follows commercial. If it's 3 stories or less, it's residential. Someone was trying to align those regardless of height of the building. That was not approved. Cool roof expansion, that was also not approved. Basically, this says increases the SRI requirement for climate zones 0 through 3 and establishes requirements for cool roofs. It's something out there now that people are awarding in above code programs, or there's also, we're part of looking at some of the weatherization of some of the buildings in a community. There's a push for cool roofs. A lot of times that is just a membrane that's applied that's either just a lighter color, it's bright white, or it has reflectivity to it, or it has some kind of UV protector in it that will reflect and not absorb the radiant heat. So it's a cool roof thing that's happening. It'll probably make it into the code somehow, some way, but the people that send up those proposals, even though they're not approved, they will turn around and do the same thing again for the next session of the code. And then also dedicated outdoor air systems was not approved, requiring commercial builders to install a dedicated outdoor air system, separating ventilation from the conditioned space. That was not approved as well. Probably will be modified and reestablished in the 2027. Renewable energy is these things get bigger as we go through. People are adding things all the time for that, not just solar, not just wind, but you've got biomass, you've got other types of sources that can be used for fuel types. Then you've got on-site renewable energy. This requires on-site renewable energy generation. It was approved as modified. Renewables definition in Appendix CC was also approved as modified. It just clarifies some of the language. And then you've got energy storage ready. So it's approved as modified. Makes energy storage ready requirements mandatory for all buildings. So if people are using battery storage or power wall storage, there's now going to be some improvements for that and energy storage ready for that part of it. So not sure if you guys saw the article this morning, but Tesla was approved for 2 virtual power plants in Texas. So that's hopefully a move in the right direction, using power walls of people and power banks that they have for the Tesla systems to be able to create a virtual power plant to help the Texas grid. So that's a good thing that can happen. Those kind of things will probably just trickle into the code as well as they become more and more used in today's standards. Electrification. So what was disapproved was commercial decarbonization. I think it's made it into the residential, but someone did not approve the one for commercial, and that would require all construction to be all electric. So that's very tough to do in Texas and Oklahoma, being that it's a gas driven and oil driven state. It's kind of tough to say you're going to do all electric. Grid integrated thermostats approved as modified. And grid integrated water heaters approved as modified. So that requires the controls for heating and cooling systems to be able to adjust by the grid standard, not individual occupants or building owner or maintenance. By the grid, if they need power consumption to be reduced, they'll be able to adjust temperatures by within 4 degrees. So it's not like they want to take a warehouse that's cooled to 76 degrees and they're going to now go up to 86 degrees to conserve energy. No, they'll only change it by within 4 degrees. It is a difference. People will notice it. But if they're doing that at the high peak for 4 to 6 hours in a day, it could keep the grid from collapsing. So that's not a bad thing that's happened. And same thing for water heating as we keep going through there. If it's electric storage, if it's gas, it's not part of the system or not part of the requirement. But if it's electric, same thing there. You're going to be able to turn it up or turn it down depending on the energy consumption that's happening with that. And then electric vehicles approved as modified. You got requires EV charging for all commercial building types. So energy storage ready is C405, requires commercial and multifamily energy storage readiness. So this is something that is just going to keep making it into the code itself. We've been contacted by another group that's a nonprofit as well that does mostly EV and solar and EV ready buildings, and they deal a lot with this on a national level. So I think what we're going to do is have them as a presenters to present their system on what they do. They have free training that goes on for you code officials and third parties that can just go on there and follow a training program that will teach you how to inspect and how to look at these type of new systems, these EV chargers, this solar ready stuff, and what to look for to say, are they compliant to be EV or storage readiness? Is it set up to do that, or is something missing in that and not completed? So that'll be brought out in probably the next few weeks to months, but look forward to that. I'm actually going to try to go through the training myself and have that as part of my presentation. But we'll go through some of that because it's becoming more apparent daily, just people using it in their buildings. And then also solar and storage inverters that was approved as modified requires solar and energy storage systems to be equipped with smart inverters for grid integrated controls. So the first inverters that were out there were very costly. They also consumed a lot of energy to be able to do. There's now smart inverters that can turn on, turn off. They can report. They have grid integration controls. That is now going to be required for commercial. And then grid optimal credits. This was withdrawn. I think they were trying to use that same points and credit standards table, but they were using it for grid optimal credits to get credits for certain things. That was withdrawn. I think they probably didn't have it completed. They didn't have it to the point where they thought they needed it, and they'll probably bring it back on the 2027 and repropose that. And then, so the first draft will be published. Okay, published on 9. Oh, it's okay. It's coming up in the next couple of weeks. September 9th of 2021. The public comment period is open till October 21st, 2021. I'm sorry, 2022. The proposed 2024 commercial model code will require all buildings to be more significantly energy efficient than those adhering to the 2021. It'll also save another 8 to 12% energy and from improved energy efficiency, reducing energy cost and greenhouse gas emissions. So as I've talked about in some of the other stuff that we've gone through, the energy code's taking a turn for not just looking at energy consumption, it's also looking at carbon footprint. It's looking for greenhouse gas emissions. There are a lot of cities that now have to plan, for funding reasons, you have to plan greenhouse gas emissions reductions, carbon footprint reductions. You have to put an action plan together. So these codes are trying to catch up to say, we can help, we can help, we can help. We can have code requirements that are there that will help you meet those efficiency goals for lowering greenhouse gas emissions, as well as reducing costs for energy efficiency measures as well. So I went through that. We're about an hour here. I know I had it slated for an hour and a half. I'll be adding to this as we go and probably redoing this towards the middle of next year, as long as we keep going with this legislative session that did not adopt the 2021. We're still unclear as to whether or not the state of Texas will do 18 or 21. I doubt seriously they're going to wait till the 2024 and adopt it. It's just too much to handle from a 15 code to a 24. So it will probably more than likely be an 18 that's not amended or a 21 that is amended to make a less of an impact. But we're going to be watching that as the next legislative session comes up in 2 years. We do have meetings all the time with supporters and stakeholders that we discuss and talk about and show the importance of energy efficiency improvements and adding to the code and getting that new adoption of the energy code. So please include the link to download the presentation. So this will actually be on YouTube not long after this. We're going to actually present it to you, but I can absolutely send out the slideshows as a PDF. I can probably just break it up into 2 and send it out to everybody. So I will do that. I'll make Kathy add that to the email. She may have to do it in 2 separate emails, but I can definitely do that as well. Some of the stuff that I talk about is in the notes. I'll try to add that to the PDF section. And the larger it keeps getting, the harder it is to send it via email. So I appreciate the request for that. It will be there. This is my contact information. Please feel free to share my contact information with anybody. I'm always happy to put on presentations, do trainings. I'll also be doing training in Houston and South Texas coming up soon. Sean's put on there 405.12 energy monitoring. If a building had a 25,000 square foot addition and required energy monitoring, how would that impact with existing systems? Like the original HVAC system plan size to handle the addition, but was not monitored. That's a great question. It comes down to on the existing side of the code on chapter 5 for the existing, if it's going to be a new addition and it's new equipment, then it should follow the energy code. So just because it's an addition, if it's greater than 25,000 square feet, it should be required to have energy monitoring. But if it's tied into the original system, like they're adding additional ductwork, but some of the systems are still heating and cooling another part of the building that's original, and then it's actually going to start doing some, if it's sized properly and you can use some of that HVAC stuff. If you don't change it out, it doesn't have to adhere to code. That's a tough call. That's kind of going to be left on to the building official to say what they want to do. More than likely, if the system is old enough, it won't be able to handle any kind of monitoring. There's not the sensors that are in place. It can't really do anything but power consumption monitoring. It won't be able to switch on and off and have fault detections. So that's a great question, and that's handled normally by the CBO or the building official that's there and how they deem that to be done. If it's an all new, brand new 25,000 square foot addition, like they're adding another warehouse, but it's attached to a building that's already existing, but it's 25,000 or more. In my opinion, everything in that 25,000 square foot addition should now be adhering to the energy code. That means energy monitoring, all of that needs to be done. But when it gets confusing is if you've got existing chillers, water heating, HVAC, if they're existing, you really can't make them meet the new requirements of the energy code, even if it's now part of the new addition. So that's a great question, the way that's put up. It's just a tough call. It's going to be down to the building official to make that decision. I had a question yesterday in a presentation that I did with almost the same thing, but it's a large warehouse and someone has an apartment or a dwelling unit that's there that they're living in. Is that, how is that handled? Is that permitted and taxed as a residential, or how do you split that up? So it almost comes down to just a judgment call by the building official. So I will end the recording here. I will remain online. We can always talk about more things. If you have more questions, we'll probably sit on here for 15 minutes or how long it takes, and people want to stay on. So I'm going to end the recording here, and then we are free and open to discuss.